Hi all. Now we are going to see how to copy an array and to shape manipulate the arrays that we have created and also to create identity array as well as an I function. So this example shows us how to copy an array. We'll have an original array and we don't alter anything in this. We copy it and we just make changes in that. So whatever changes we do in the copied array will not affect the original array. So here first an array is created with this value and this is the copied array. We copy the entire array in this. Now I change this first one, which is nothing but the first index is being changed or it is included as 42. So it is the one is replaced by 42. So the original array will be different from the copied array. We'll have a copy of it. The original data will be saved in that copied array and the new one or the changes what we do in the array will not affect the copied array. So this can be used to save the data or the original raw data that we have already obtained. Next is manipulation of the array, shape manipulation, which is nothing but reshaping the array. Means very simple. We are just trying to reshape a one-dimensional array to two-dimensional array or two-dimensional one-dimensional to three-dimensional array. Let us check how we try to reshape it. The function is dot reshape. So this is the original array and this is a one-dimensional array. We try to create or reshape this one-dimensional array into two-dimensional array. And here for this to be done, we write it as dot reshape and we specify the number of rows and columns or the shape specifically. We have seen the array attributes. You can just refer the previous video of mine if you have doubt in the shapes of the array. So here it is just classified into 4 rows because we have given 4. First represents the row and second represents the column. So 1, 2, 3, 4 rows are created with 3 columns. So it is just reshaped by this way. So now one dimensional array is reshaped into a two dimensional array. Now let us check how a one dimensional array is being reshaped to a three dimensional array. Again we use dot reshape. Here this is our array, one dimensional array that is created. We try to reshape it as this way. So two stacks, 3 row and 2 columns. So it is this 2 stacks, 1, 2 and 3 rows and 2 columns. This is how the data is being split. So this is how we try to shape manipulate or reshape. And this is another way of converting or trying to do, or it is just, this is another reshaping. We try to convert whatever maybe the shape, it is a two-dimensional or three-dimensional array into a one-dimensional array. So here this is the original array that has been created and we try to reshape by -1, which is actually this is 2D, so it is converted to, when you do -1 it is one-dimensional array. So this is how we get the final answer. So we can either convert one-dimensional array to two-dimensional or three-dimensional array, or likewise we can even change or reshape a two-dimensional array to a one-dimensional array by the same dot reshape. In case of one-dimensional to two or three-dimensional array, we have to specify the number of rows and columns and the stacks, whereas the axis values. In case of converting to 2D or 3D to one-dimensional array, we have to just put it as dot reshape. In the bracket we have to put it as -1. Next comes the identity matrix. So identity is very simple. You'll have the diagonal elements to be 1 and the remaining elements are just filled by zeros. So this is how we create a square matrix in which all elements other than the diagonal elements, main diagonal elements, will be 0. Main diagonal elements will be 1 and all the other elements will be 0. So it is the syntax is numpy dot or np, you can write np dot identity. We have to say the number of values and then the d type. So it is just 2 rows, 2 columns, since it is a square type we mentioned. So it is 2 cross 2. So when you write 2, it is 2 cross 2. So here it becomes the diagonal elements alone will be 1 and the remaining will be 0. Instead, if you put 3, it becomes 3 cross 3 like this. And you can either put it d type, nothing but the data type, it is integer. So if it is float, it becomes 1.0 or 0.0. That's it. So it is the diagonal elements are 1. So in order to create a square matrix with the diagonal elements, main diagonal elements to be 1, we use the dot identity and we specify the type of like the square number of rows and columns n cross n. There's one more function which is called as I function. Here, same like your identity function or identity matrix, the diagonal elements will be 1, but it is not like, you will be having only the main diagonal, you can have anywhere. We'll just check the syntax first and we'll see the example so that it is easy for us to correlate and understand the difference between an I function as well as an identity function. So numpy or np.I, we specify the number of rows and columns here, and k is nothing but the index of the diagonal. I'll explain this with the, if we don't give any value, it starts from this position. If in case we write k equal to 1, then it starts here. Okay, and d type can be float or int or whatever it is, and order is C, means row, or which is main, row major or column major. Okay, so if in case I don't specify anything, it is just the normal thing, n and m are same, number of rows and columns, then k represents the diagonal value or where I have to start from the reference point of the diagonal. Either if it is 0, then it starts here. If it is 1, k equal to 1, it starts here. K equal to 2, it starts here. And so it just goes on. We can see with an example, see np dot I2, which is actually written as this is imported numpy as np and np.I2, which is we are creating for a simple 2 cross 2 matrix. If it is 3 comma 3, it is just 3 cross 3 matrix, simple. The same like the identity matrix. Now let us see the difference here. This is integer, this is basically float because default it just keeps a dot. Here it is an integer, and here n is given 5, and obviously 5 cross 5, m is not specified, k equal to 1, and that is why it starts here, it is not starting here, and so it starts here, and d type is integer, so no dot is available, means no, it's not a float value, it's just the integer value. So if I give k equal to 2, it starts here, and I'll have only 3 values of 3 ones available. So if I don't mention any k, or if I just write it as k equal to 0, it starts with this place and all these values will be 1. So the difference between the I and the identity matrix is, by default, in identity matrix, if I write 5 or just 5 comma 5, it creates a square matrix of 5 cross 5, and the main diagonal elements will be 1. Remaining elements will be 0 in an identity matrix. Whereas in the I matrix, it is like we specify where the 1 should be in the diagonal, and so we give the k value. That's the main difference we feel in case of I and the identity matrix. Thank you.